Gravity is pulling you down toward the center of the earth right now. Why aren't you going there? You say, the floor stops me. But the floor is made of atoms, which are mostly empty space. You're made of atoms, also mostly empty space. Why doesn't the empty space of you slide through the empty space of the floor? The answer isn't solidity. It's a rule of quantum mechanics that forbids two things from being in the same place. We live our lives assuming that things are solid. You knock on a door, it makes a sound. You sit in a chair, it holds you up. It feels continuous. It feels like stuff. But this is a lie your senses tell you. If we look at what you are actually made of, the concept of solid evaporates. Let's use the classic analogy because it works. Imagine we take a single atom from your finger and blow it up until it is the size of a professional football stadium. The nucleus, the protons and neutrons, where almost all the mass lives, is a marble sitting on the 50-yard line. And the electrons? They are tiny specks, smaller than gnats, buzzing around in the highest rows of the bleachers. Everything in between the marble and the gnats is nothing, vacuum, empty space. So if you are a stadium full of empty space and the floor is a stadium full of empty space, why is there a collision? When you walk, it should be like two galaxies passing through each other. Mostly stars missing other stars. You should fall right through the floor and keep falling until you hit the center of the earth. The fact that you don't requires an explanation that is much deeper than friction. The first answer people usually give is electricity, and they aren't wrong, they just aren't looking deep enough yet. Surrounding that nucleus are electrons. Electrons have a negative charge. The floor also has electrons with a negative charge. And as you learned in grade school, like charges repel. When you step on the floor, the electrons in your shoes are pushing against the electrons in the concrete. They despise each other. The electromagnetic force is billions and billions of times stronger than gravity. So gravity pulls you down, but electromagnetism screams, get away. So you are hovering. You are floating on a cushion of electromagnetic repulsion about 100 millionth of a centimeter thick. You have never touched anything in your life. But wait. This explanation has a hole in it. If I push hard enough on a magnet, I can overcome the repulsion. If I push hard enough on a gas, I can compress it. Why is a rock so stubborn? Why is solid matter so incredibly hard to squash? If it were just electrical repulsion, you should be able to squish atoms together if you squeezed hard enough. But you can't. Matter fights back with a ferocity that electricity alone can't explain. To understand why the floor is hard, we have to look at the personality of the electron. In our everyday world, everything is distinct. If I have 2 pennies, I can scratch one. Now I can tell them apart. This is penny A, and that is penny B. But in the quantum world, this is impossible. Electrons are not just similar, they are identical. Fundamentally, absolutely identical. You cannot scratch an electron, you cannot tag it. If you swap 2 electrons, the universe literally cannot tell the difference. This seems like a minor detail, but it leads to one of the most important laws in the universe. Because they are identical, they follow a very strict social rule. They are what we call fermions, and fermions are the introverts of the universe. They refuse to party together. This rule is called the Pauli exclusion principle. It states that no 2 electrons can occupy the same quantum state in the same place at the same time. Imagine a parking lot. In the human world, if I park in spot A, you can park in spot B. We are close, but we are distinct. But in the quantum world, the state includes things like location and energy. If an electron settles into the lowest energy state around an atom, the parking spot closest to the nucleus, it fills it. If a second electron wants to join the atom, it cannot go into that lowest spot. It is forbidden. It has to take a spot further out at a higher energy. It has to go to the upper deck of the parking garage. Think of the Pauli exclusion principle as the universe's traffic cop. It says, this space is taken, move along. This is actually why chemistry works. It's why we have a periodic table. If electrons didn't have this rule, they would all pile up in the bottom energy level. Every atom would behave exactly like hydrogen. There would be no chemistry, no biology, no you. So back to the floor. When you step on the ground, gravity is trying to crush your atoms against the floor's atoms. It is trying to force the electrons to share the same space. But the traffic cop says no. To squeeze those atoms closer, you have to force the electrons to overlap. But since they can't be in the same state, The only way they can overlap is if one of them jumps to a higher energy state. It has to speed up. It has to vibrate faster. This is connected to the Heisenberg uncertainty principle. If you try to confine an electron to a smaller and smaller space, its momentum, its jiggling speed must increase. This implies a cost. To squeeze matter, you have to provide the energy to make those electrons jiggle faster in those higher states. Here is the deliverable. Solidity is actually an energy tax. When you say the floor is hard, what you really mean is, I do not have enough energy to pay the tax required to overlap these electrons. Gravity is pulling you down, but the energy cost of squeezing your atoms into the floor's atoms is astronomical. The universe demands a payment you cannot afford, so you stop. You stand. Is it possible to break this rule? Can you ever pay the tax? Yes. But you need more than your body weight. You need the weight of a star. In a massive star, gravity is pulling inward with mind-bending force. For millions of years, the heat of the star pushes back, but eventually the fuel runs out. The heat stops. Gravity wins. The star collapses. It crushes inward. It squeezes the atoms so hard that it overcomes the electronic repulsion. It overcomes the Pauli exclusion principle for electrons. The electrons are smashed into the protons. They merge. They become neutrons. The empty space of the atom is annihilated. The stadium is crushed down to the size of the marble. This is a neutron star. A teaspoon of it weighs 1 billion tons. This is the only way to fall through the floor. You have to crush the empty space out of matter until it isn't empty anymore. Unless you weigh as much as the sun, the Pauli exclusion principle remains the undisputed champion of your reality. So let's rewrite your intuition. When you walk down the street, you aren't walking on solid ground. There is no such thing as solid. You are a collection of energy fields and mathematical probabilities. The ground is a collection of energy fields and mathematical probabilities. You don't fall through because nature has a fundamental law that forbids identical particles from sharing the same identity. It is a stubborn refusal to share space. Solidity is an illusion created by the high cost of compression. You are held up by the fact that electrons are antisocial. They demand their own space, and because they do, you get to stand on the surface of the earth instead of shrinking into a microscopic black hole. I think that's a pretty good deal. The universe is strange, it looks solid, but it's a rule-based hologram of forces. If you learn something new about why you don't fall through the earth, and why it's not just friction hit that like button, it tells the algorithm that we want more deep physics and less surface-level stuff. And if you want to understand the deeper rules of these particles, the traffic cops of the universe, I've linked a guide to the fundamental particles in the description. See you in the next one. Like this video if you learn something new about atoms. It helps us break the algorithm's exclusion principle.